Good morning, kids. Today we're going to finish up our new material on sequences with Handout 10-4, which is the explicit formula for geometric sequences. So I will be able to determine the value of any term in a geometric sequence. That's our goal for today. So if we were together, we would be doing this explore activity kind of in class, and you would try to be figuring it out on your own. So we're going to graph the sequence 32, 16, 8, 4, 2, and so on, and we're going to use the table if we need to. So the first thing I want you to do is to describe the pattern of the y values. So if we take a look down here at our table, the term value is our y and the position is our x. So to get from 32 to 16, 16 to 8, we are multiplying by 1/2. So if we go to graph this, we'll take a look at what it's going to look like. So again, our first position is 32. Our second term, or our second position, is down to 16. Our third term is down to 8. Fourth term is 4. And the fifth term is 2. So I'm hoping you're taking a look at this and you notice that this graph is nonlinear. Alright, if you remember from yesterday, we said the arithmetic sequences modeled a linear model, but a geometric sequence models a nonlinear. It actually looks like exponential decay, and it's very similar. Some differences are the domain of a geometric sequence is different than the domain of an exponential decay, and also the base can be negative in a geometric sequence. But overall, what I want you to understand is that this geometric sequence is nonlinear. Alright, so for part C, we said it's geometric, so therefore it has a common ratio, and that is 1/2, because every time we are multiplying by 1/2. Alright, here's some notes similar to what we had the other day, but we're just going to repeat it. There are two rules for sequences. We have the recursive rule, and we have the explicit rule. Okay. What we're focusing on today is the explicit rule, which defines a sub n as a function related to the term's position in the sequence. So we can find any term number based on its position. And what we did the other day or last week was the recursive rule, which defines the value of a term by relating it to its previous term. Alrighty, so this geometric formula is given to you. You do not need to memorize it, and this is what allows us to find any term of a geometric sequence. It's a sub n equals a sub 1 times r to the n minus 1 power. So in here, a sub 1 is the value of the first term, r is the common ratio, and n is the term number, whatever you're trying to find. Okay, and again, this is given to you, so you don't need to memorize it. It is on the reference table. Alright, so we're going to break this up into 3 sections again. The first section is using the explicit formula to find any term number. So class example 1. Find the 8th term of a sequence whose nth term is represented by a sub n equals 4 times 3 to the n minus 1. Alright, so all we have to do, because we're finding the 8th term, is substitute in 8 everywhere we see n. So a sub 8 equals 4 times 3 to the 8 minus 1 power. So we have 4 times 3 to the 7th. That's going to give us the value of the 8th term. So I'm going to put this in my calculator. 4 times 3 to the 7th power, and I got 8,748. Okay, as you can see, it's growing pretty quickly because we have a base of 3. Class example 2. Find the 15th term of a sequence whose explicit formula is represented by a sub n equals 5 times the quantity -2 to the n minus 1 power. So now we're looking for the 15th term. So I'm going to substitute in 15 everywhere I see an n. Now all of this is going to go into your calculator. Be careful, the base here is -2, so you're going to want to put that in parentheses. I'm going to put in my calculator 5, and then in parentheses -2 to the 14th power. 81,920. Alrighty, the next section is finding the explicit formula given the sequence. Remember, the explicit formula is the specific formula that works for that sequence only. So there's tons of different explicit formulas because there's tons of different sequences. So class example 1, find the explicit formula for the sequence 3, -6, 12, -24. So what we would do is we would go back to the reference table and grab the formula that's given to you right here, the one that's in the bubble. So I'm going to write that down first. Now to answer this, we need to know two things. We need to know the value of a sub 1, so that's our first term. A sub 1 here is 3, and we need to know the value of r. So what's happening every time to get from one term to the next? We are multiplying by -2. So the common ratio is -2. Now all we have to do is substitute that in. So a sub n, which is any term, is going to be 3 times -2 to the n minus 1 power. And that's it. You leave it just like that. And then you can substitute in whatever number you need. All right, let's try one more. Find the explicit formula for the sequence. 960, 320, 320 divided by 3, 320 divided by 9. So it's asking for the explicit formula, so we'll write out a sub n equals a sub 1 times r to the n minus 1. That's what's given. Now we need to come up with two things. We need to know a sub 1, which is the first term, 960, and we need to know the common ratio. We want to know how do we get from here to here, and here to here, and so on. Okay. It might not be so obvious to you. So if it's not obvious, you're going to take any term and divide by the term before it. So I'm going to start, and I'm going to do 320 divided by 960. I got 1/3. Okay. I'm going to test this again. So now I'm going to do this term, 320 thirds, divided by 320. So you should try this as well. Make sure you're using your calculator correctly. So I have 320 thirds, I grouped it in parentheses, divided by 320. And I got 1/3. So our common ratio is 1/3. We're multiplying by 1/3 every time. Now that you have that, all we have to do is substitute it in. So a sub n equals 960 times 1/3 to the n minus 1 power. And we leave it just like that. So that's the explicit formula that you could use to find any term number here. So for example, if you were asked to find the 20th term, we would now substitute in 20 instead of listing them all out. All right, the last section, I said putting it all together. So it says, find the 10th term of the sequence -7, -21, -63. So this is where we have to do both. First, we're going to find the explicit formula, and then we're going to use it to come up with the 10th term. So the explicit formula is going to be in the form a sub n equals a sub 1 times r to the n minus 1. Now to do that, we need to come up with a sub 1 and r. So looking at our sequence, the first term is -7, and the common ratio is 3. So our explicit formula is going to be -7 times 3 to the n minus 1 power. All right, that's your explicit formula. Let me write that down, or I'll bubble it in a different color. Now we're going to use that explicit formula to find the 10th term. So now I get to substitute in 10 everywhere I see an n. So a sub 10 is -7 times 3 to the 9th power. I'm going to put all of that in my calculator. Okay, a sub 10 equals -137,781. So that's the final answer to this question because it asks find the 10th term. You can see how quickly these numbers are growing because of the geometric nonlinear model. Alrighty, finally, class example number 2. Find the 15th term of the sequence 5, 15, 45, 135. So again, this is where we put it all together. So first we're going to find the explicit formula, then we're going to use it to get the 15th term. So it's going to be in this form, which is given. Now we need to come up with two things, a sub 1 and the value of r. Taking a look at this sequence, a sub 1 is 5, and every time I see that I'm multiplying by 3. So that's my common ratio. Okay, let's substitute in. A sub 1 is 5 times 3 to the n minus 1. All right, I'll bubble that in again because that's our explicit formula for this sequence. Now I'm going to use that explicit formula to find the 15th term. So now I get to substitute in 15 for n. Alrighty, so the value of the 15th term is 5 times 3 to the 14th power. Oh boy. 2, 3, 9, 1, 4, 8, 4, 5. $23,914,845. Wow. Okay, so that is geometric. Remember, geometric is a nonlinear model, so your numbers tend to grow very, very quickly. We have the explicit formula, which is in the form a sub n equals a sub 1 times r to the n minus 1 power. That's given. So you're going to use that to come up with the explicit formula, or use it to find any term number. I left you with some independent practice examples, and I also left you with a forms activity that I want you to do today. It's 10 questions. So make sure after you're done with this, you click on the link in OneNote and complete the forms activity. All right, thanks so much.